And here we go. Right, so um, welcome to a very short live stream on the sort of build progress of the Ant CNC PCB mill. This is going to be a very short stream. Last stream was 3 hours long, 3 hours and a half long or something, I think, almost four. This is not going to take nearly as long. I've already built the head and bridge, as we can see here. So everything's working pretty nicely. Um, Everything's pretty smooth. Some modifications may be needed, but there was a lot of work put into this because there are things that I feel like the end team didn't perfectly account for, and there were some things that I personally had to account for myself, and because of material availabilities. So first of all, there's the bearings. The linear bearings that I got from Amazon. They were pretty cheap, but also they are fairly low quality. So whenever whenever I tried doing the two bearings, hammering one bearing in each side of the part thing and pushing in a rod, all the connections started super rough, which is as expected. But the bearing themselves were pretty rough. Not just so the roughness wasn't just caused by misalignment, it was caused by the quality of the bearing themselves. Something that can be sort of adjusted for using extra lithium grease, which I don't have at the moment, but I could uh, possibly get if that becomes a problem. Um, but also there's the fact that these bearings, because of the roughness, a few balls sort of popped out during the assembly, which I had to go and search for. On the live stream I did, I actually popped out a ball from one of these linear rails, but here I didn't pop out one ball. I popped out probably like 10 or 12 that I found. I know for a fact that I there was one ball that I could not find, one ball bearing I could not find, but at the end of the day, it's fine. It's working pretty okay. The z-axis is snagging a tiny bit, but I mean, I could always use the heating method to realign the bearings, which works wonders, by the way. And a small comment on this, on their video, they say to use the heat gun over the plastic at 160 degrees Celsius for PLA for some seconds. I I saw that just doing like 30 passes, 30 slow passes, 10 times with probably 10 seconds of rest in between was pretty yielded pretty good results and could be repeated until you got the you until everything was nice and smooth. The only thing is, when doing this, I would heavily suggest that you keep the rod inside for as long as the part cools down. Because if the rod isn't inside when it's cooling down, I saw that it doesn't completely go back to its original shape, but it sort of still stays deformed. And so when you put the rod back in, then it's rough again. But if you let the rod inside, as it cools down, it keeps the shape that you want for the most part. Yeah, so that heating method is very, very good, very useful. It's even more useful when you start using, assembling both rails, because in some cases there are very small parallelism issues, especially with the bridge itself. And if you can just, get the heat gun to go over um, where the bearings are just to assure that the alignment is right, you can also try and flex the bridge parts to, get nice and parallel bars, although these bridge parts do have a significant width and these rods are very, very hard, so they're not flexing at all. It's not that hard to get good parallelism out of this, but it's still better if you can realign the bearings inside properly so that everything is running nice and smooth. Um, So yeah, one interesting thing, I said that the bearings inside were rough by themselves, and now that there's two of them, it's a lot smoother. But also there was significant improvement by heating. I still not am not sure why that is. I imagine it may be due to the lubricant sort of because it's grease, right? So it may have like somewhat liquefied and spread over more evenly, but I'm not super sure of that. Interestingly, when I did this, at some point when I hammered one bearing in, I actually popped one of the seals. So a lot of balls fell on the ground, and the bearing was sort of semi disassembled. The interesting part of this misadventure is I never found this seal ever again. I have no idea where it is, and considering that I did end up finding 15 ball bearings, so like 12, 15 ball bearings by themselves, and that I couldn't find a bearing seal, which is much, much larger and much easier to see than those parts, it kind of boggles my mind. At any rate, what I ended up doing is taking a bearing seal from the one bearing I had left, although I do not have any extras. I had yet to hammer one bearing in, and I placed it inside of the bearing that was already hammered in. And then for that bearing, I replaced the missing seal with a 3D printed part. So here, right here, we can see the white 3D printed seal. It's not great. It's three layers of filament, which is very, very thin, but it sort of does the job. And I haven't had any problems once it's been inserted as of now. I will get extra bearings, and I will also get the recommended upgrade from the end team, which is the bushings. And I'll probably try and use that at a later date, but for now, that's what I have. So, yeah, so one thing about this whole bridge and head assembly, the whole motion with the rods, is these guys here. The holes, they say to drill with 6 millimeters, a 6 millimeter drill bit, which is not a bad idea because here you don't want the rod to go in too easily. You don't want them slipping around, but you actually don't want them to be too difficult to insert. If you need a hammer to insert these rods, like they show in the video, I found that it's actually probably not the best because you want to be able to sort of move these parts along, even if it's relatively difficult. You don't want obviously the rod slipping, but you are going to need to reposition these bridge parts when you place the entire assembly inside, and then you have to sort of stretch them out to get on, grab on the carriages of the linear rails. And so because I only have imperial bits, I had to work with sort of limited types of measurements. I couldn't get an exact 6 millimeter drill bit. So I first tried drilling with a 15/64 drill bit, found that it snagged too much, and for some reason, I guess it was too early in the morning, I said, oh, it snags too much. Let me just go one size higher. So I drilled with 1/4 inch and then placed the rod there, and I was like, hey, this is slipping nicely. That's what we want, right? No, that's not what you want. You should stop at 15/64 if you only have access to imperial bits, and then maybe do something with the drill where you sort of go in and out, and then with your other hand holding the part, sort of try and make a rotary motion to try and expand the diameter a tiny, tiny bit, and that tends to do the job nicely. That's both for these bridge parts and the top and bottom head parts. Then yes, so there's these rods here, these 100 millimeter 3 by 3 rods, threaded rods. Essentially, what they make you do in the video is that they make you create these very, very long bolts by super gluing. Can't really see at the bottom there, sort of. You're essentially super gluing a luck nut on the tip of one of these, and I don't have super glue, so I settled for quickset epoxy, and it does the job fine. It's honestly there's probably a lot of things you could use instead of super glue to try and create that wanted desired geometry, and I mean it's not very difficult. Probably the lock nut itself could be used because of the nylon lock. I wouldn't be surprised that that works. So that's not a big deal, especially considering that these rods, although convenient to sort of strap everything together, aren't particularly load bearing. So the biggest problem I actually ran into when doing this, besides the whole bearing stuff, which wasn't too annoying, but was extremely long to get the alignments just right, especially with the cheap bearings I had, was these bridge parts. Uh, with the lock washers I have, the opening and these bridge parts for the pulleys was way too short. If I tried to put everything together, first of all, okay, putting the three lock washers and two pulleys was literally impossible. I unless there was some way of like compressing the lock washers properly, even the one you are inserting at the moment, it was probably impossible. And I did try remove a small bit of material to make the opening a bit wider, and then the pulleys were very, very, very difficult to move around. So what I had to, I actually measured the opening width required using the lock washers I got, and the nominal opening of the parts. So not just the opening I had on my printed parts, but the opening described in the step files, and there was like a difference of 1.25 millimeters, which may not seem by much, but it does all the difference for this stuff. And it's quite a significant amount of material to remove as well. The problem is I couldn't just reprint parts that had been slightly modified because its step files as present on the Bitbucket repository are sort of broken. There's missing surfaces, which means that CAD softwares will not let you literally do anything with them because, I mean, obviously there's missing surfaces. The program's sort of confused there. And it's, I guess, not defined as a solid per se, which is also strange. So instead, I had to actually go and try and sand down the inside here to get a larger opening. But because the opening is quite an awkward shape, I actually had to go with like a Dremel bit and sort of grind down a bit awkwardly and then try and smooth everything out with a bit of sandpaper. Ended up working in the end. It's not very pretty, but now the pulleys are pretty loose, and everything is fine. I mean, I understand that the lock washers the team had at that point were probably more than good enough for them and were just the right size, and they probably did all the required measurements. The only thing is, the step files being broken right now or missing surfaces is a big problem, and maybe this could be ideally this would be addressed uh, so that people can just go in and modify the parts slightly if required. So lastly, I actually also fit a uh, the waste material bed to this. So it's not very difficult because in the frame assembly, they actually make you assemble the bed holders for the most part, except like these two thumb screws. And the only problem I had is that here it's very difficult to put your hand on 10 millimeter thick MDF board, or I don't exactly remember if this is MDF, but it looks like it, so I'm gonna call it MDF. And what happens is I have to buy a board which is half an inch in thickness, which is 2.7 millimeters thicker than your usual uh, than the nominal 10 millimeter thick board. And so I had to actually go in and modify these holder parts here to make it so they could account for a bit of a thicker waste material plate. And honestly, because the step files were fine, working perfectly, this was not really a big problem. And I could just modify them, print them, install them, and everything went smoothly. So now, to evaluate the project right now, so everything is moving smoothly. All the pulleys are nice and smooth. And then we have, this movement here of a fairly smooth X and Y movement, a bit snaggier of a Z axis movement, which I may have to modify in the future. Although this isn't like the requires the best of precisions really. Some precision is required to modify the thickness of the trace of the well, not the traces, the thickness of the cuts in the PCB, but it's probably not the most critical axis. I don't feel like it would be. I feel like the positional axis would be a lot more important. And one thing that's particularly important for this is if you're building this and you want to see how smooth your axes are, do not try and see, okay, X is fine, and then, okay, Y is fine. Because this isn't really how the machine is going to move around. Because it's a core XY machine, the axes are actually these 45-degree movements like this. So if you can take, so because the bends are going to go around here, if you can take this rod and sort of move or take it around this section, sort of move it at 45-degree angles and it's smooth, then that's good. That's good because that's your base movements essentially. Right. So, I mean, I've also run into a bit of a problem with with this screw here, but that's entirely my fault. The way I'm using Simplify 3D, and I found that the way the slicer works with holes is that it makes the shell of the hole, but it doesn't attach it as sturdily to the rest of the part as I sometimes want, especially when you want to thread something in it that has a bottom. Because then what happens is that if you screw too hard, then the shell disconnects and it sort of rotates with the screw, and then you're kind of screwed. um, so what I did is I pulled out the screw and the shell together, unscrewed the shell from the bolt, inserted the shell back in, used the soldering iron to sort of get it back into a single piece, and very, very um, carefully screwed in the bolt back, and now everything's working fine. Um, the the end switches are clicking nicely when they're reaching their end states, so I'm not really concerned for that. I think it's gonna be just fine. So the project is well on its way. And next up is going to be the electronics. So just preparation of the wires. I think that's an entire video by itself. I've already dabbled in some of the stuff, like the headphones trick, which I found is not particularly convenient because they make it seem like it's very easy to simply go ahead and uh, just unsheath the headphone cable, test it, and then just solder it back on. But it really isn't because proper design of headphones require a lot of other materials like glass fiber. Not, I don't think it's glass fibers. It might be, but some kind of fibers to relieve the stress from the metal cables, which is intertwined with everything. And then there's different levels of sheetings. There's um, plastic coatings on everything. It's very, very difficult to actually try and parse through all those cables and make sure that the connections are where you want them to be, especially considering that most of the headphones I have at my disposition to do this, I have them because I can, afford to sort of break them like that because the wires are broken and they're not working anymore. So I either have to hope that the wire is broken at the headphone or close the headphone, or that the headphone itself is broken, which never happens. It's always the wire, and it's always at the base of the jack connector. So what I ended up doing is try to harvest a male jack connector from one of the headphones, which I did successfully. And now I'm going to actually put my own wires on there at, at the proper length, and hopefully that works fine. So that was it for today. Hopefully I can get some progress in on the wires and connectors, even though I do have some things to do now. But I should do an update video like this probably tomorrow. The thing actually this video was supposed to do yesterday, but I didn't record the audio properly, so now I'm doing it again. All right. Well, thank you very much, everyone, for watching, and I'll see you next time.